All right, so triangle mid-segment theorem. Again, it's dealing with midpoints today. We are dealing with midpoints. Okay, when you think of mid-segment, you got to think of midpoints. Section 5.4 here. Vocabulary, just as we said, a mid-segment of a triangle is a segment that joins the midpoints of two sides of a triangle. So it's a line that joins the midpoints. So if I give you a triangle here, okay, a mid-segment would be something like that right there, where it cuts the triangle essentially really in half, going from midpoint to midpoint. Now, if you were to look at that triangle, I have given you a mid-segment. How many mid-segments would you say are in a triangle? Think about it. Do not shout it out. How many mid-segments would you say are in a triangle? What do you say, Troy? There are actually 3 mid-segments in every triangle. Because there would be one, and because they'd go there. And then I could do the other one right there. It's coming down.
It's going to quit again. No, Troy, I only got it.
Okay. So here's what it looks like then. So triangle mid-segment theorem, again, as we just said, a mid-segment of a triangle joins the midpoints of two sides of the triangle. And as we said, there are 3 mid-segments in any given triangle, essentially. There are 3 of them. Now again, what's important about this? Well, it goes from midpoint to midpoint, so with the triangles, basically, the sides are cut in half. Recognize that. Okay? And there are some interesting properties that we're going to discover here with the first couple problems. So, number 1 here. It says, use the figure for exercises 1 to 4. AB is a mid-segment of RST. Okay, AB is a mid-segment of RST. First thing it says is, what is the slope of the mid-segment of AB? So as I look up here, I have AB. Now let's recall from yesterday. What's another way to think of slope? Instead of using the slope formula, I can do what? Rise over run. Okay, slope is rise over run.
2 over 2 is 1.
Now, some of us were struggling with this yesterday in our homework. As we think about it, is that slope going to be positive or negative? Negative. Remember, negative slopes go down. Positive slopes go up. That is true for all slopes. That's something you can always need to find right away. Some of you do a great job of finding rise over run, but then you switch up the negative and the positives. Recognize, negative slopes will always be going down from left to right. What is the slope of that purple line right there, Camden?
Negative 2 over 2, that equals 1.
So the slope is negative 1. I agree. Again, we went down 2 over 2. So you found the slope, negative 2 over 2. Now I'm going to do the next line, which is what I'm going to call my red line here. It says find the slope of ST. Okay, and again, what does slope mean again, Jessica? Rise over run. Jessica, would that be a positive or negative slope, first of all? That would be a going down, so it's negative slope. What is the slope of ST, Anna? What? I couldn't hear you, what? Oh, T's down there. This is the red line.
1.
Okay. It'd be negative 1. What do you notice about the slopes of those 2 lines? Camden, what do you notice?
They're the same.
They are the same slopes. If they are the same slopes, what do we know about the 2 lines then, Drew? They are parallel. So number 2 says, what can you conclude? Well, they are parallel. That is always true. You need to know that today. I can give you a lot of lines that look to be parallel. It could always just be slightly off. I mean, you have to be proven first.
Wouldn't the perpendicular slope be positive?
Yes. Okay. But yeah, mid-segments are always going to be parallel to the third segment. That's true for all triangles. Next part here. I'm going to find AB and ST. So I want to find the actual lengths. So I want to find the actual lengths here. For instance, I want to find the length from A to B. What's one way I can find the length there, Mr. Goldup? Distance formula. Or the other option would be Pythagorean theorem. Which method would you like to choose, Noah? Okay, so Pythagorean theorem says to draw a triangle. So what's the two sides of my triangle, Noah? 2 and 2. So I would have 2 squared plus 2 squared, which is
4.
8 equals c squared. So AB is the square root of, because the last step in Pythagorean theorem is always take the square root. So I have the square root of 8. Somebody with a calculator, please. I will allow you to use a calculator here. What is the square root of 8 to, give me 2 decimals, please. 2 decimals, square root of 8.
Bryce, go.
Anybody? Anybody's got a calculator on them?
I got you. 2.82.
2.82? Thank you, sir.
See, I had two. Those ones.
It's still
I wasn't even understanding.
Okay, so everybody great. ST, square root of 8 is about 2.82. Great. Now the next one says to find the length of ST. So now I'm going to find the length of ST. Again, if I need to find the length, there's 2 options. What's one of the options, Tyler? Pythagorean theorem. What's the other option, Jack? Which one do you want to choose, Jack? Pythagorean. Oh, whenever you have coordinates out there, it's always easier. Just do Pythagorean theorem. It's very easy. So I draw my right triangle. Great. What are the 2 legs of the triangle then? Oh, Max, what are the 2 legs?
4 and 4.
Great, 4 and 4. So I get 4 squared plus 4 squared equals c squared. 4 squared is 16. So I get 32 equals c squared, which means ST is the square root of 32. The square root of 32 is approximately what, Bryce?
565. No, that's right. That's
It's about 5. Now we are approximating, right? I'm gonna say 564 just for sakes here. 564. If it rounds up, now we are rounding. Understand that.
565.
Okay. What do you notice about the 2 distances here?
One's like double.
It's double. Or another way to think of it is it is.
Twice as big.
Or another way to think of it is it is.
Twice as big.
Other way to think, instead of twice as big, it's also half. Thank you. Okay. So when you compare the lengths, what is it? AB is half ST. That's the other thing you need to know for today. Those 2 things. So A, they're going to be parallel. The mid-segment and the third side of the triangle are going to be parallel. And then B, the mid-segment is always going to be half of that third side. Okay, and that's what you need to know for today. And that is always true. And then the reverse would be ST is twice the mid-segment. Vice versa on
It
this.
doesn't matter which way you go.
No, we're going to be going both ways today, actually. So here's what it says. We just proved this. But a mid-segment of a triangle is parallel to a side of the triangle. We just talked about that. And how do you denote parallel lines? Well, you have arrows, usually something like that. So those 2 would always be parallel in a triangle. Okay. And then the second part we learned was it is half. So for instance, up here, it gives me this triangle. It says AKC is 12 right here. What does HJ have to be then? HJ has to be what, Troy? 6, because it is half of that third side. Nice job, sir. All right, we're going to take that information and we're going to work through some problems here. So the first one here, number 8. I want to find each of the 4 measures. Number 8 says find Vx. So I want to find Vx, which is the red line on the triangle. What is a way I can find Vx? What do you say? Jersey, what are you thinking, man? What did you say? equals which one?
WB.
It would not equal WV. This is the mid-segment. So that one's going to be very similar to like that segment. So what are you thinking, Troy? Yeah. It's going to be half of that because mid-segment on the third side. So Troy, what's VX then? 23. Because it is half of 46. There's nothing that says the mid-segments are congruent to each other. Okay, the mid-segments are not going to be congruent. It's half of the third side, though. We do know that. Okay, we do not know that the mid-segments are congruent to each other. What about number 9? It says find HJ. So now I'm going to go HJ. Here's the blue line. HJ is the blue line. What do you suppose that has to be, Mr. Goldap?
54.
How did you find that?
Because the mid-segment's 27.
Yeah, if that one's 27, you take 27 times 2, and you get 54. Good work. All right, now comes the tough one here. Angle VXJ. So I want this angle right here, this purple angle right there. Now, some of you might be looking up there going, they don't give us enough information on that triangle to find that. But you can find VXJ. What are you thinking, Max? What do you know about the triangle? Let me throw some lines up here for you. What do you know about these two green lines right here? They're half. They're also what? We found two things out. They are what? They're parallel. So they're half. Great. That helps us with distance. They're parallel. That's going to help me find the angles. So what does that purple angle have to be then, Troy? It has to be 92. Why is that, Troy? Because of corresponding angles. Nice job, sir. Nice work. And then the very last one says to find XJ. So I want to find that distance right there. What is the distance for XJ going to be? Austin, what do you think? How'd you find that? Yeah. That whole thing is 54, so take 54 divided by 2, and I can get 27. Another way is this is 27, so each of those would be 27 then. Does that make sense? All right, moment of truth. Let's see what we've learned here. What if I gave you this angle in, I'll pick up kind of a pinkish color. What if I gave you that angle right there? What would that angle right there be, Kay? How do you know that? Corresponding angles. Nice job. All right, let's try another one here. What if I gave you, let's go with this yellow here. What if I gave you this angle right there? What would that yellow angle be? Peyton?
I know it.
Give me something. What are you thinking? If you can't go get it, I'm going to Gabe. Oh, I thought you had your hand up.
I did, but I thought you were calling somebody else.
What would it be, 88?
Mr. Boger, it is 88 degrees. Why is it 88 degrees? You're correct, Michelle. Why is it 88 degrees?
That's 2 for Nick.
This is 92. It's a line. The line has to be 180, so that one has to be 88 degrees. You can find a lot of these different angles just by knowing that information. All right, take a couple seconds. Try these 4.
Where are 5, 6, and 7?
Let's check, see how we did. ST. So I want to find the distance from S to T. This, if I can get the color red, this red line right here. What's that distance going to be, KZ?
72.
How'd you find that?
Because I took 36 times 2 and I got 72.
Yep, you would do 36 times 2. Nice job, sir.
Thank you.
Number 13, I want to find DE. So I want to find this blue line. Right there, Mr. Frost. How'd you find that? Half 44, good work. All right, now came the little bit tougher ones. I want to find angle DE. Find angle, let's see here. I put this green angle right here. What do you think, Ryan? It is 48 degrees. How do you know it's 48 degrees, sir?
Since ST and DC are parallel, TE would be the transverse.
Very good. So that means those are what type of angles right here? Those are alternate interior angles. Nice job, sir. And the last one, I want this orange angle RCD. What would the measure of that orange angle be? Okay. And why is that one 48 degrees? That'd be another example of alternate interior angles. Nice job. All right. One last thing. Tough question here. Let's see who can figure this out. We have not, well, you would have done these in some type of class, probably. This shape right there, that is purple. Do not blurt it out. Do not blurt it out. Who can guess what shape that would be? Do not blurt it out. Give everyone else a chance to think about it. What shape, and I'll give you a clue. Yes, this is a quadrilateral. I want the specific name of this one, though. You raise your hand for serious this time.
Yeah.
What is it?
Parallelogram.
That is a parallelogram.
Good job.
Nice job. Opposite sides are congruent and opposite sides are parallel. That is a parallelogram. Nice
Yeah, it
job.
looks kind of weird. There's purple on there too.
No, it is.
Hey, since you got it so quick.
Here's your assignment.